Hi everyone, welcome to our channel TechTwins for Data Science. This is our second video in a series of multiple videos related to data analysis. Video 1, we talked about the right skills to land your first job as a data analyst. So you can check it out on the top corner of your screen. This is Ronnie. I'm a master student in my second year, and today we will talk about data analysis types and techniques. And the main characteristic of each type. Then we will talk about the data quality and how to avoid any bad data quality traps. But before we get started, please remember to subscribe and hit the bell to receive a notification every time we publish a video. And feel free to share your opinion down in the comment section. You can also support us by liking this video. Let's get started. We have different types of data analysis. The first type is descriptive analysis. So we will use the dataset and observation to answer the question, what happened? The next type is inferential analysis, which answers the question, how likely one event occurred, or does an event has an effect, or we don't have much evidence to support this hypothesis. Third type, which is predictive analysis, and we will use the observation in the dataset to answer the question, what is likely to happen in the future? Fourth type, diagnostic analysis, which answers the question, why did it happen? That will be based on the historical data. Fifth and final type, which is prescriptive analysis, that answers the question, what is the best course of action? Let's get started with the first one, descriptive analysis life cycle. It is the first step in data analytics. It identifies the current and past data records to identify trends and relationships, as well as give us prime detection of any wrong observations, such as outliers, missing values. It highlights also the benchmarks. However, it doesn't give decisions. We need to use other analysis, such as inferential statistics, by, for example, implementing A/B testing, but this is for another topic. Let's focus on DA. Descriptive analysis, or DA, example while generating KPI dashboards. KPI is key performance indicators that the companies use these multiple metrics to highlight the business performance. Descriptive analysis, it also describes the features of population and or samples and answers the question, what happened, by using the data to understand the main features. Descriptive analysis can be employed using statistics such as the measure of central tendency, mean, median, mode features, also the measure of the spread such as range, quartile, percentiles, and the standard deviation, and the measure of symmetry, right skewed, symmetrical, or left skewed. Using, for an example, Python, we can, if we run the describe function, we can collect the mean, median, mode, quartile, standard deviation matrix. And by using the histogram or .hist function, we will definitely can identify the symmetry of each variable. Moving on to inferential analysis life cycle, it helps in making generalizations about the dataset based on representative sample of the population. It enables us to create predictions, as its results are usually in the form of probability. It's crucial to select a sample that's randomized but still representative of the larger population. Statistical inferential can be divided into three areas: point estimation, interval estimation, confidence interval, or hypothesis testing. When it comes to predictive analysis, this type of analysis is super important and massive industries are based on. It enables to use every piece of information to forecast future events. Sweet example here, if we talk about Uber trips, so the fare is based on three factors: fixed fare, distance in kilometers, and duration in minutes. Predicting taxi fare means measuring the distance upfront, taking into consideration the traffic time, the route fees, and the surge figure. The surge, which is the number of riders versus the number of drivers in a specific area. And then the application runs an estimate before even the rider submits the request on the application. So it is based on the variables in the dataset and the correlation between those variables. So it divides the independent variables from the dependent variables. Back to my example, the Uber trips, we can take into consideration that the trip fare is dependent variable that we need to predict, and the distance and time are independent variables. This section in particular, we have a whole video to cover later on. Stay tuned. These types comes after descriptive analysis for sure. Moving on to the diagnostic analysis, it is dedicated to measure the business performance, identify the business performance gaps, operation challenges, then it provides effective solutions for these variables or these problems. By using the historical data and current economy situation, this can be conducted using regression analysis. However, I need to highlight one important point: the correlation versus causation. Correlation means we have multiple variables that are correlated with each other, and correlation range is usually between -1 to 1. -1 indicates strong negative relationship between variables, while 1 represents strong positive relationship between variables. 0 represents there is no relation at all. We have three main types: negative, positive, no relation. So let me give you an example here. We can assume that the higher education degree can increase the chances of getting higher position in corporate. So this example, we can mark it as a positive correlationship. When it comes to the negative correlation, let's assume that the lower temperature leads in consuming coffee or hot drinks in general. So positive correlation between variables means these variables are moving in the same direction, while negative correlation means one variable moves up and the other variable moves south. It might not only mean two variables, it might be multiple variables, but we stick to just two variables here for illustration. If you are enjoying this video so far, please give it a thumb up and click the subscribe button to support us. Thank you so much, and let's continue this video. Prescriptive analysis. When we speak about prescriptive analysis, we mean the bigger picture. This type might be taken while building up your presentation and set recommendations to the stakeholders. After running your analysis and summarize your findings, you will have a possible scenarios to choose the best one among them. Simple example like what Google Maps app is doing. Like a user add his start point and destination, then Google Maps highlight the best route possible. This type requires to have the skill of problem solving and storytelling. As easy as it looks, it can be challenging to be able to implement the mechanism in real life. And then we have data analytics investigation or approach. So assume we have a problem question and we also have a dataset. So your approach will start by first planning and preparations, second collecting the data, third analyze. As we implement the different forms, in simple cases it may consist only of consideration of data in a table or diagram. For this purpose, we use a combination of descriptive statistics and inferential statistics. And finally, presentation may consist of graphical illustrations and a summary of results, conclusion, and practical recommendations. Our second part of our video, data quality definition and dimension. Before starting our analysis and generating some insights, we need to make sure that we have a really good quality of dataset. Otherwise, even with all the modeling and deploying, it will get us back to square one. The consequences of failing to recognize that we have a poor quality dataset is even worse. Even if we use train test evaluation split technique, as in machine learning models, the data needs to be representative of the population. Such as harm of the bad data quality is a significant on business decisions by stakeholders. As you can see here, we have 4 pillars, started with the accuracy, which is established the data that reflects the reality, which impacts on accurate reporting and confident decision making. The second pillar in data quality dimensions, timeliness, indicates the data is available when expected and needed. Third, consistency, achieves when data values don't conflict with other values within a record or across different datasets. Fourth, completeness, indicates the critical variables in the dataset is complete or not. Also, the data affects the reliability of insights that gathered from it. How to overcome bad data quality traps. There are some rules to avoid such a trap. First, investigate your variables and make sure the data is not imbalanced. If you have imbalanced data, then you need to do more investigation to fix this type of data. And I will talk about all this type, the imbalanced data and structured and unstructured, in the next video. The second part, the data sources shouldn't be older than 10 years at maximum. This might challenge, but still it will be based on the industry itself. Third, run statistical tests to give you insights, such as detecting the data format, outliers, search duplicate data. Maybe your dataset contains some incomplete values or missing data, and you need to estimate the ratio of this missing data. You need also to see if there is inconsistency between the variables or any invalid dates or negative values that not should be required or shouldn't be exist in this dataset. Let me know down in the comment section if you need me to go in more depth in this topic of data quality and big data principles in general. And finally, we have 8 websites for finding any dataset you want. We're starting with Kaggle, as I have mentioned before. It contains thousands and thousands of datasets in different sizes and different formats. And I will definitely add all the links for these websites down below my video. And second website, Dataset Search by Google, and then Gapminder World, DataHub, UCI machine learning, FiveThirtyEight Datasets, awesome public dataset, and finally OpenML or Open Machine Learning. Thank you so much for watching, and if you like this video, please give it a thumb up and don't forget to subscribe and hit the notification bell. Also, you can follow us on TechTwins for data science on Instagram and TikTok